this video we are going to solve problems on combination of resistors. So before that, let me tell you how to identify these series and parallel combinations. See, if the current flowing through all the resistors is same, suppose we have these three resistors connected to a cell and the same amount of current I is flowing through this resistor also, this resistor also, and this resistor also, then they are said to be connected in series. And if they have resistance R1, R2 and R3, then the equivalent resistance of these three resistors will be R1 plus R2 plus R3. But if different amount of current flows through them, let's see this example. If we have, say, these three resistors are connected in this way, okay, these three resistors are connected in this way, R1, R2 and R3. So if I current is flowing through this circuit, then I1 current goes here, I2 goes here and I3 goes here. So these three are said to be connected in parallel, and to find the equivalent resistance we have this formula: 1 by R equivalent is 1 by R1 plus 1 by R2 plus 1 by R3. And if n resistors are connected, then we will go to 1 by Rn. Here also we will go to Rn plus Rn. Okay, so we have seen this. Now let's move on to the problems. Okay, so here we have a 6-volt battery and these three resistors are connected in parallel, as you can see. So we have to find that how much current will flow through each resistor. So see, since they are connected in parallel, so the potential difference of all these three resistors will be equal, and it will be equal to 6 volt. Okay, so if suppose I current is flowing, then let's say I1 current goes here, I2 goes here and I3 here. So I1 will be V by R1 from Ohm's law. V is 6 volt, so this will be 6 divided by 5 ampere. So I1 will be 1.2 ampere. Now I2 will be, I2 is equals to V by R2 similarly in the similar way. So this is 6 by 10 ampere, this is 0.6 ampere. And I3 is V by R3, this is 6 divided by 30 ampere, this is 0.2 ampere. Now we are asked to find the total current flowing through this circuit. So the total current is I, and I is equals to I1 plus I2 plus I3, which is 0.8 plus 1.2, which is 2 ampere. So 2 ampere of current is flowing through this circuit, 2 ampere. Now we need to find the equivalent resistance of these resistors. So see, we have V, we have I, so we can find R. R is equals to V by I, which is 6 volt divided by 2 ampere, which is 3 ohm. So the equivalent resistance of these three resistors is 3 ohm. You can also verify this by the formula that we have seen, that 1 by R equivalent is equals to 1 by 5 plus 1 by 10 plus 1 by 30. So this will be equals to 1 by 3. So R equivalent will be 3 ohm. Okay, now let's move on to the second question. So in the next question we have this circuit. Here we have R1 is 2 ohm, R2 is 3 ohm, and R3 is 4 ohm, and R4 is 2 ohm. And we have to find the equivalent resistance between these 2 points A and B. So suppose if current I is flowing through this circuit, suppose let's connect this to an imaginary cell. Suppose current I is flowing, then I1 will go here, I2 will go here, and I3 will go here, and this I3 current will flow through this R3 and R4. Therefore R3 and R4 are in series. So the resultant of these two will be 4 plus 2, it is 6 ohm. The resultant of these two is 6 ohm. Now these three are in parallel. So 1 by R equivalent is equal to 1 by 2 plus 1 by 3 plus 1 by 6, which is LCM is 6, 3 plus 2 plus 1, which is 6 by 6, which is 1. Therefore R equivalent is equal to 1 ohm. The equivalent resistance of this circuit is 1 ohm. So in the next question we have these resistors, and all of them have the resistance of 2 ohm, and we need to find equivalent resistance between A and B. So see, these two are connected in parallel, because if current I flows through here, then I1 will go through here and I2 will go through here. Similarly, these two are also in parallel, these two are also in parallel, and these two are also in parallel. So the equivalent resistance of these two is 1. See, 1 by 2 plus 1 by 2, which is 1, and take the reciprocal of this, so it will also be 1. So let me replace these two by a 1 ohm resistor. So let me replace these two by a 1 ohm resistor. Similarly, this and this also by a 1 ohm resistor. So we will get a figure like this. This is 1 ohm, this is 1 ohm, this is 1 ohm, and this is also 1 ohm. Now see, if I current flows, then I1 will go through here and I2 will go through here, and this I1 current will flow through these two, and this I2 current will flow through these two. So these two are in series, and these two are in also series, and they are in parallel. So 1 plus 1 is 2 ohm, and the combination of this is also 2 ohm, and these two are in parallel. So 1 by R equivalent is equals to 1 by 2 plus 1 by 2, which is 1. So R equivalent is equals to 1 ohm. So the equivalent resistance of this is 1 ohm. So in the next question we have a square A, B, C, D, and these resistors are connected like this, and all of them have a resistance of 2 ohm, and we need to find the equivalent resistance between A and B. Equivalent resistance between A and B. So suppose it is connected to a cell like this. So if I current is flowing, then after reaching this, I1 current will flow through here and I2 current will flow through here. So see, this I1 current will flow through R4, R3 and R2 and then reach B, and the I2 current will only flow through R1. Means I1 means R4, R3 and R2 are in series. So let me replace them. These three are in series, 2 plus 2 plus 2, which is 6. So 6 ohm. Now these two are in parallel. So we have R equivalent equals to 1 by 2 plus 1 by 6, which is, and then 3 plus 1, which is 4 by 6, which is 2 by 3. Therefore R equivalent is equals to 3 by 2 ohm, which is 1.5 ohm. So the equivalent resistance of this is 1.5 ohm. Okay, now let's move on to the fifth question. Okay, so here is our last question. Here these resistors are connected like this, and we need to find the equivalent resistance between A and B. So connect them to an imaginary cell for understanding. So see, I current is flowing through this cell, then after reaching here it will break into I1, I2 and I3. This I1 current will flow through R1 and R4. Okay, so R1 and R4 are in series. So let me draw it once again. This is R3 equals to 2 ohm. This is A, this is C, and then this is R5 equals to 2 ohm, and then this is R2 equals to 2 ohm. Now this R1 and R4, let's call the combination as R6. So R6 will be 2 ohm plus 2 ohm, which is 4 ohm. So R6 is equals to 4 ohm. Now let's connect this to a battery or a cell. Here is our point B. Now notice I current was flowing. I1 goes here, I2 here, and I3 here. Now R6 and R3 are in parallel. It is visible. See, here I1 current is flowing and here I2 current is flowing. So these two are in parallel. So let me replace these two by one resistor. So we have, this is our point A, this is B, and then this is C, and the combination of these two. See, if I call the combination of R3 and R6 as R7, the 1 by R7 is equals to 1 by 2 plus 1 by 4. So which is equals to 4, and then 2 plus 1, which is 3 by 4. So R7 equals to 4 by 3 ohm. So this R7 is 4 by 3 ohm, and this is R5, which is 2 ohm, and this is R2, which is also 2 ohm. Now I current was flowing. Now the current that will flow through this resistor will also flow through this resistor. The current that will flow through R7 will also flow through R5. Therefore, R7 and R5 are in series, and this is in parallel with R2. So the equivalent resistance of R7 and R5 will be 4 by 3 plus 2, which is 3 to the 6, 10 by 3. 10 by 3 ohm, and this 10 by 3 ohm is in parallel with 2 ohm, so the effective resistance 1 by R equivalent will be 1 by 2 plus 1 by 10 over 3, which is 3 by 10. So this is 20 as LCM, 10 plus 6, which is 60, divided by 20, 4 4s are 4 5s are, so R equivalent is equals to 5 by 4 ohm, which is 1.25 ohm. Therefore, the equivalent resistance of this circuit is 1.25 ohm. So that's all for today's videos. Hope you all like this, and if you have any doubt regarding this, know in the comments below, and thanks for watching.